COX produced persistently could cause asphyxiation and global warming. Noting that the source of energy used in the production of deodorant stick is coal, specifically low-grade coal, which contains approximately 2% of sulfur. When subjected to combustion, would result to production of harmful gas known as SOX and could cause an impact such as photochemical smog and acid rain. Consequently, NOx is also produced during the combustion process when nitrogen and oxygen are present at elevated temperature and can lead to eutrophication when not contained at a minimal level. Also, VMS or volatile methyl siloxane, which is a type of volatile organic compound, could create tropospheric ozone and petrochemical smog.
Ingredient formulation is critical in deodorant making, since each raw material has specific components that contribute to the hardness, consistency, and appearance of the final product. The formulation presented in this study is adapted from the energizing deodorant stick formulation of the Dow Corning Company. All the unit operations considered in the manufacture of deodorant uses coal as the main energy source. The production process begins with materials handling, in which the raw materials are delivered to the manufacturing plant as bulk powders packaged in sacks, and as liquid materials sealed in metal drums and barrels. These are then transported into the plant with the solid materials loaded in pneumatic conveyors, while the liquid materials are transported in compartmentalized equipment that include a liquid siphon to ensure that the raw materials do not react unnecessarily.
Initially, rotary batch mixers are employed for pre-processing the two batches of raw materials in order to achieve proper mixing. Phase A includes liquid lauryl PEG, cyclopentasiloxane and cyclohexasiloxane, coconut oil, and stearyl dimethicone. The powdered and key ingredients are C30-45 olefin and C30-45 alkyl methicone, and mainly functions as a film formers and or viscosity increasing agents, non-aqueous in cosmetic products, and also as a lubricant and conditioning agent, respectively. Phase B includes liquid propylene glycol, bis PEG-18 methyl ether, dimethylsilane, propylene glycol, and D1-alpha tocopherol acetate. The powdered ingredients include sodium chloride, ascorbic acid, and ginseng extract. For both mixers, they emit harmful emissions that could cause detrimental impact in the environment, such as SOX, NOx, COX, PAH, and VMSS. The formulation would then be mixed in furnace 1, where the steam heats the solution at 75 degrees Celsius. The main deodorant mixture from the furnace would then be subjected and enhanced in a kettle mixer. The formulation is made by agitating the mix and heating to a temperature of 75 degrees Celsius with steam as the source of heat until a viscous solution is obtained. To add scent in the mixture, active bright fragrance is applied. Since water has been adversely affected in quality by anthropogenic influence, parameters such as turbidity, TDS, TSS, color, and BOD are taken into account.
Viscosity test is carried out to make sure that the product has the right consistency and meet the highest standard. In this test, the solution is stirred at a constant speed. Then the force required is observed whether it is within the accepted range. Recyclable overspill is sent back to the kettle mixer to again meet the specifications. Dented containers and non-recyclable overspill are now considered solid waste of the process. In a filling system, a system of lever raises the containers to align with filling nozzles that dispense the mix. A system of rotating wheels keep the containers moving. One wheel conveys them to the next for filling, and a third wheel that leads them out. Dented containers and non-recyclable overspill are the solid waste produced in this process.
The dispensed hot mixture in the container must be hardened. That is why it is placed in a refrigeration tunnel. Inside the refrigeration tunnel, an overhead rake evenly lines up the containers. The containers will stay inside the refrigeration tunnel for several hours to harden the mixture. Solid waste produced in this process is non-recyclable solid overspill. Cooled sample of deodorant is administered through hardness test. An apparatus called force meter is used to measure the amount of pressure required to crush the sample. It should just fit the right specification. Those cooled samples that didn't pass the quality control would now be considered as solid waste of the process, namely the non-recyclable solid overspill.
Containers are conveyed using conveying wheels. In a conveyor, sensors are installed to make sure that the containers together with the dispensed mixture are well encapsulated. And the solid waste produced in the process are dented containers. From the conveyor, the containers would then go to the next station, which is the doming station, where each container gets one plastic cover. Again, a system of rotating wheels keep the containers moving and conveys the containers through the station. And the solid waste produced in the process are dented cups. The capped containers then move to the next process, where they receive a plastic strip that seals the perforation. Sealed containers would then pass through the automated smoothing brushes, where it removes any adhering material that might be present on the containers, and also to ensure that plastic seals are properly attached. Afterwards, final touch is being conducted by labeling the sealed containers. Rejected seals and tags from these three processes are collected as solid wastes.
The finished products are now confined in boxes and ready for delivery!
An industrial plant cannot avoid producing solid waste upon the application of each processes to obtain a specific product. That is why a specialized facility is built to receive, separate, and prepare recyclable materials known as Materials Recovery Facility. In the deodorant production, the solid waste are collected and classified into two. First is the non-recyclable materials, which will be transported to landfills. The other is recyclable materials. When wet, it will undergo drying. If not, It will go directly to manual sorting and then transported to junk shops.
Effluent collected from each process should undergo these so-called wastewater treatment processes. This is to achieve improvements on the quality of the wastewater. Wastewater from the production of deodorant will first be subjected to primary treatment. It includes screening, batch separator, primary clarifier, sequencing batch reactor, and equalization tank. Then it will proceed to secondary treatment. It involves supercavitation, aeration, drying, sedimentation, and bioreactor. To further enhance the quality of the water, tertiary treatment is employed, which only involves disinfection. The effluent is treated and can now be discharged to any form of bodies of water.